everyone. I'm Shivam. Welcome to today's session on production grade programming. Before we begin, just wanted to know how many of you have gone through the notebook before attending the class? Okay, okay, cool. Uh, okay. Sure. I think many of you have gone through this. I think so. This is a very important part, right? So before coming to the class, please go through the notebook once so that you get a brief context of what is going to be discussed, right? And that will help you in understanding the concepts in the class as well. Okay, that's great to know. So today's topic in particular, right? So very important topic, but some of you have seen that this is kept in optional, right? I'll tell you the context, right? There is this these things that you are learning from the past few days, right? So Python basics and how to write functions, how to write for loops, how to write indentations, and all the basics, right? This lecture will be slightly different. For many of you, it will be difficult to grasp in the first go itself, right? So there is no need to worry. It's quite it's this topic is in a slightly different league from all the other topics that you have studied. Of course, there are some things which will be in common, but yeah, so slightly tricky concepts. And I'll tell you where you will be, utilizing the knowledge that you'll gain today, right? So this is when you are in your very later stages of your data science life cycle, right? So once you start doing projects, right, those will be in your collab notebooks. You'll be developing some hypothesis testing, building models around it, right? Post that, right, how do you organize your code, okay, so that it is reusable by the end user, as in anyone who is reading your code can understand what is going on. And again, uh, your code should not throw errors, right? So when you are running your codes uh, right now during development, right, so you try a lot of things, you uh, encounter errors, and then you fix that error, and then the code runs again, right? So these are some probably till now you have encountered some syntax errors, something like that, right? Later on there will be you'll be writing some codes wherein there will be non-systematic errors, as in the code might throw an error which you do not know of, right? So when you are working with APIs, third party APIs, so there you'll be writing some codes which might throw an error, not while development, but while it is getting used in production. So which brings to the concepts of today's class. So what is production, right? So when you start coding and you start with a project, right, so you write codes which we call as the development stage, right? So you are developing some hypothesis around the business problem, and then you are structuring some codes. Then comes the stage wherein you are confident that whatever codes you have written is solving the business problem, right? And now you want it to actually be used by the end user, right? So just for an example, right, so in case of Uber, let's say you wrote a model which predicts the price for from A to B, right? So now when you book a cab, in the app you see a price, right, when you put the from and the to location, right? So you get the price. So what is happening internally is there is some module, some data science module, machine learning module, which is working in the hindsight, uh, and giving you that price, right? It is showing you that price. Internally, there are a lot of codes probably thousands of lines of codes getting executed within a millisecond to provide you that output. But still you see in some cases your app throws an error, right? So it says that some encountered some problem, something like that, right? So there can be non-systematic errors in your code. Those should not ideally in an ideal case those should be those systems should be 100% error proof, right? But we so how do we ensure that? So we ensure that while productionizing it, while we are shifting the developer grade code to a system wherein it will be automatically running. You will not run the code. It will automatically run based on, let's say, whenever a user requests for a cab, it will run automatically. In that case, right, you will uh, your code should not throw error at that point of time. So you have to build certain constructs so that when you are shifting from development to production, your code should work well, right? So that is what we'll be trying to do. But just keep in mind that this is um, for now it's kind of optional, right? So we have kept this lecture at this point in the curriculum because it's part of Python, right? And not that much necessary going forward, right? So even if you, let's say, do not attend today's class, it's totally fine. But at some point later stages, when you are well aware of all the workings of your uh, models, at that point you will see some use cases, right? So right now you'll not use this content in, let's say, the coming uh, 8 weeks, right? So 8 to 12 weeks you'll not be using this. Okay, but still if you're able to understand and able to write your codes in a structure that um, you will learn today, it will be helpful for you, right? So that's it, right? So uh, particularly two things that I want to cover today. Okay. So one is object oriented programming and another one is how do you handle errors and exceptions. Okay. So let's start with object oriented programming. So uh, like you must have in your previous lecture encountered terms like methods, right? method Methods, functions, and might be wondering what's the difference, like kind of does the same thing. One operates after the variable name, one operates before the variable name, right? So what's the difference, right? So today we'll try to uncover those things, right? So you'll be able to appreciate in a better way what exactly a method is, right? So in particular we'll be covering a few topics like objects, the use of the class keyword, how do you create class attributes, and then how do you create methods in a class, and we'll learn about a very interesting topic called polymorphism. So let's start. So you must have heard about objects till now, right? So you have learned integers, booleans, and then lists, tuples, dictionaries, right? So everything in Python is kind of an object. Okay. So for example, a list is an object, right? So the type of that object is list, right? But essentially all the variables that you have, in fact everything in Python is kind of treated as an object. Okay. So you write so this is just an example. So you can initialize an empty list, right, by just writing a square bracket. So this is an empty list, and then another way to write this is list, right? So uh, uh, you define that this is kind of a list, so you just write list and parenthesis. So this is also one way to define an empty list object, right? Then you have probably used something like append, right? So in a list you have used something like index in a list, right? So all of these have various utilities, but this is what as methods, right? So uh, consciously or subconsciously you have used these terms, these things, right? Now we'll just try to understand in a bit deeper manner how these work, right? So to append basically a particular value into a list or a particular item into a list, you just call the append method. Okay, so this is how you can do that, right? So you can keep on appending uh, objects or items into a list object, right? Similarly, you can find out the index of any particular item in a list by just writing the item number, the item value, right? So here, if I want to know what is the index value of this number 3, I'll just call list dot index, and I'll pass this argument which is 3, and it will return me 2, because this is the 0th index, first index, and the second index, right? So index number is 2 for 3. Okay, so here today what we'll try to do is, can we create objects? So here you see you have, a list is certain type of object which has some predefined methods and and attributes, right? So this append method is pre-built, right? So maybe this will not work in an integer, right? So in an integer value, if you want to do a dot append, it will throw you an error saying that integer kind of objects do not support this method append, right? You'll get an error. If you read it correctly, it will say something on similar lines, right? So you can just, we can try that as well, right? So let's say I define a integer, okay, and then I write in an integer I want to append 2. Okay, so see, so it says that int object, so a is kind of an int object, right? Int type of object. This has no attribute append. Okay, it says that I do not understand what append is. Okay, so int type of objects do not understand what append is. So in Python, someone has probably defined what methods will work in what type of objects, right? So append, index, all of these type of uh, uh, methods that someone might have written in the backend of Python, which you are able to readily work on, right? So that's why dot append method is used. But so you understand that not all objects will have all the methods, right? So what has someone written inside so that in only in list objects, let's say append is working, or only in tuples or dictionaries append is working, not in, let's say, int. So what goes behind that, right? So let's try to create some objects of our object types of our own today, right? So that is something which is very powerful, right? So you can customize uh, your own set of types of objects. You don't necessarily have to work with only, let's say, lists, dictionaries, or tuples which are defined already in Python. Let's say you want to create another type of object which has some other utilities, right? Which has its own methods, right? So can we just do that? So this is what we'll see. Okay, so so as I already discussed, in Python everything is an object, right? So you can write a variable name. So I've taken this the sixth sense, and then if you print the type of it, it will show you class int, because this is an int type of an object. Okay, so you see, notice the two terms that is getting printed when you print the type. One is class and one is the int, right? So it says that this object is of the class int, right? Of the type int, right? So again, for float type of objects, right? So let's define a variable 2.5 min, right? So 2.5 is the value that I assigned. If I print the type of it, it says class float, right? So the type of this object is float, the class is float, right? Then again, so you can define a list, right? So it says class list. Another list, you can, if you define, and it will also say class list, right? So you can define a dictionary, right? So basically can have a dictionary named Tharud, let's say, and then for this key Farago, you have, let's say, one string as the value, which is a confused mixture, right? So if you print the type of Tharud, which is a dictionary kind of an object, it will say class dict, right? So it denotes that the class has been no, the class or the type of this object is dict, right? So till this part, anyone has any confusion regarding what object is, and what do you mean by type of an object, right? So you got some sense of what is class, right? Class is nothing but the type, right? Type of the object. Anyone any questions till this point? No, right? Okay. uh, okay, cool. Cool. So let's move ahead and try to see how can we create our own class of objects, right? So let's say I want to create something like list, but it will support my kind of methods, right? So I want to take control of that, right? So we can define that in Python. Okay, so this is the interesting part. Okay, so let's try to define a class. So basically you have to define a class or a type, right? So list type, right? So let's define our own kind of type, which, let's say, I'm calling as the first class. Okay, so similar to list, I want to define a, a class or a type of objects. I want to create type of objects whose type is first class. So when I do a type, I should see class of first class. Okay, so similar to this, right? So it should print similar to this. So Python has a syntax for that. So you just have to write class, and then you have to write the name of the class that you want to create, first class, and then colon, right? Inside that, you can write a whole lot of things, like what methods will it support, right? And what attributes will it support. So all kind of things you can write. But for now, just to demonstrate how you can create a class, just the creation, still till now I have not defined how that type of object will work, right? So all those methods and everything I have not defined yet, right? So I have just defined the I have just created the type of that class. Why I have written pass here is that if I do not write pass and I run this, it will throw an error, because uh, when you say class first class and then you put a colon, Python starts expecting that he will write something, right? So he will write some method or something right there. So if it is expecting that and you are not writing something, it will throw an error, right? So to handle that, to say to Python that, right now I'm not in a mood to write anything as of now, so you'll just write pass, right? Otherwise it will throw an error. Okay, so I can just show you that. See, it will throw an error saying that unexpected end of EOF while parsing. So it could not find anything here, right? So it was expecting that you have defined a class. Now you'll, of course, do something inside it, right? Uh, so so basically that's why we write pass, right? So I created a class. Now the instance of first class. Okay, so I'm now creating an instance. Okay, so just remember, right now what we have defined is kind of a list, let's say, right? But you have to create an instance of it, right? So here, if you see, we are creating an empty list, which is an object of the type list. So how do we do that? So we write uh, empty list equal to this, right? So equal to a notation that Python has pre-built or hard coded, right? Another way to do this is this, right? So another empty list saying that this is the type of this object is a list. So this is how you initialize a object. So this is also called an instance, right? So or instantiation. Okay. So sorry. So so similar to how we wrote here, right? So how we wrote here, we will write something like this here, right? So here x is the object that I created, which is of the type first class. That is what I have defined on my own, right? Now we wanted something like this, right? So when we print the type of it, when we print the type of this, it should write something like this. So this was our whole aim, to create own kind of types, right? So can we so you can see that we are able to do that, right? So if I do print type of x, I am able to create uh, 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 an object which is of the class first class. Okay. You might be wondering what is this part, right? So main, this just shows that you have created this class and it is not inbuilt, right? So you have created it in this namespace or in this collab, something like that, so you can understand it in that manner. Okay. So it just says that you have created a this x is of the type first class. Okay, so you can just ignore this part. You can see we are able to create our own type of objects, right? So we'll not just be restricting ourselves to list, dictionaries, and whatever is already predefined. We can create our own as well. Okay, so just to give you a demonstration, we can create further objects, right? So here we created a list, here we created a list, and then we created another list, right? So and the type of both the list, the objects are same, which is the type is list, right? Similar to that, we have created this uh, object y, okay, which we are again defining, you know or writing as first class parenthesis, right? And this, if I print the type of y, this is again same as x, right? So it is of the type first class. Okay, so uh, so yeah, um, so one question I'm getting here, class keyword is creating an object? No. So here class uh, keyword is creating a class, right? So it's like, uh, here you see, right? So this is an object. This is a class type, right? So we are essentially creating something similar to this, right? Once we have created something similar to this, we can create multiple instances of this type, right? So when you are writing codes, you can create n number of lists, right? 10 list, 20 list, right? You're not restricted to just one list. You can create multiple lists, right? But for that to work, you have to define what is a list, right? So you have to initialize your objects as lists, right? So when you write something like 1 2 3, you are basically saying that create a object which is of the type list, right? And the value of that list is 1 2 3, right? So you are essentially saying this when you are writing this. Okay, so using the class keyword, we are creating class. It's very self-explanatory, right? So class is what? Students in a school are divided into classes, right? So um, uh, you say that this student studies in this class, this student studies in this class, and so on. Correct? So uh, so you can think of the students in one particular class as objects of one particular class, right? And so on, right? So okay. What is an instance? So now I think Sumanta, you must have gotten this part, right? So instance is nothing but, so you just imagine when I say class, just imagine a school wherein there are many classes and objects are nothing but the students in one particular class, right? So these are kind of objects of one particular class. So all the students in that school are kind of objects, right? And they belong to different classes, right? So each object is of certain kind of class. Okay. Okay, so now we will go to the next topic, which is attributes and methods, right? So you probably have not heard of the word attribute till now, but method you have heard, right? So for every type of object, there are certain type of supported methods, right? So as I gave an example, list kind of supports append, index, right? And probably many others, right? So you have heard of this term method, right? So not every type of object supports different kind of methods, right? So let's say let's again take the example of that school, right? So uh, in every class, let's say different topics are taught, right? So class 5 students will know the subject matter of class 5 only, right? Class 6 will know the subject matter of class 6 only. So if you go to class 5 and ask some concept of class 6, right? So you will say that this is out of syllabus. This is where your Python throws an error when you start doing dot append on int kind of thing, right? So you are basically asking a int kind of a class to show the properties of list kind of a class, right? Uh, so this is what a method is. So for every type of object, there are predefined set of methods that will work on that, right? Based on the type of class that is uh, uh, class of the object, right? So that is method. Similar to method, you have attribute, right? So you can think of method as something which you want to perform on the object, right? And attribute is something which is already there in the object, you just want to extract it, right? So it will be more clear here. Okay. So when I wrote pass, right, I just wrote pass to just so that how classes work. Now instead of pass, we'll be writing a few things. Basically, we'll be defining our own set of methods, right? And we'll write some own set of uh, attributes. Okay, so it's like taking the example of the school again. So now I'm going to teach one particular class. What is the subject matter for that class, right? So I'll teach the topics of the syllabus for that particular class to the class, right? Otherwise they will not be able to answer the questions, right? Otherwise these methods will not be able to work, right? So we need to define methods and attributes for inside a class construct, so that we are able to use it when we create certain instances of those classes. Okay. So now let's see how we can do that. So for creating an attribute, uh, we have to write something like so here I will introduce a keyword called self, right? So this you do not have to bother much, right? So just understand that there is something called self keyword which I have to write. Okay. So uh, let's define another type of class so that it's more relevant and you'll be able to relate more. Okay. So class dog. Okay, so I am defining a class which is called dog. Okay. Right, so now let's say we have uh, this this construct, right? So I'll try to explain what this is doing, but this is more or less very standard syntax that you need to write. You'll not be probably able to understand in depth of why we are writing this, but just try to understand the construct. Okay. So inside class, uh, now I am writing. Just notice the indentation. So after colon, similar to how you write a for loop, right? So you give certain indentation and then you write whatever is inside the for loop, right? Otherwise, Python will not understand that it is inside. Okay. So inside of class dog, after indentation, we will write all the codes, right? All the functionalities, everything that we want that dog type of objects to do, we'll write all those things here. Okay. So this is the first thing that you have to write. Okay. So kind of, I'll just make it more simplified. So this is something which you have to uh, anyway write, right? So here, this is like a mandatory thing that you should always write inside a class. It's kind of mandatory, and it's a good practice to write a method called init. Okay, so you'll understand more, but just think that we have to write this. Okay, for now. Now, I want to uh, derive certain attributes of a particular class. Okay, so what do we do? So I am defining two attributes of the type dog, right? So if you if you just construct um if you just take the animal kingdom as a whole, and just imagine that we are creating something for, working with dogs, right? So we have created a class called dog, right? So maybe we want to use this dog construct to create instances of dogs, right? So let's say there are 50 dogs in certain in a certain place, and we want to work with those 50 dogs, right? So for each and every one we cannot define a new construct, right? So we'll define a class called dog, right? And then we'll define certain attributes a dog should have. Okay, so so here we are kind of defining two attributes. One is breed, another one is name. Okay. So breed and name are the two attributes that I want every dog kind of objects to have, right? So dog type of objects, so definitely have breed and name. So this is the kind of construct that I'm trying to do, right? So what I will do is that uh, along with self in the init method, I will pass to uh, two variables, right? So this is uh, kind of similar in construct if you think about functions, right? So the construct wise it looks similar. Okay. So I'm saying that to initialize a kind the object of the type dog, you need to pass two attributes. One is breed, one is name. Okay. Since I have not defined any uh, default value to breed and name, you will have to mandatorily define breed and name whenever you are creating objects of the type dog. Okay. So and then so this function argument part is over. Now similar to functions, what you have to write here is that self dot breed equal to breed, self dot name is equal to name. So basically what I am trying to do is that breed and name are the two are kind of the two attributes of the class dog, right? So let me make it more clear, so that these names do not coincide. So I'm just writing that these are the two attributes, right? What values these two attributes will take, the user has to provide. Okay, so the user will provide breed and name, which will get stored in two variables called breed underscore atr, denoting that this is the attribute, okay, that we want the dog class of objects to have, right? So just wrote this. Okay, so breed and name will have to mandatorily put whenever we are creating uh, objects of type dog. Okay, so now that let's say there are two dogs. Okay, so we defined a class to define dogs, right? Now there are two dogs. Okay, So the name of the first dog is Sam. Okay. And the name of the second dog is, let's say, Frank. Okay. So now we want to create objects, right, which will correspond to Sam and Frank. Correct. So Sam object, I have defined this as a variable. Sam object is equal to dog, right? So how this is working? So if you remember, we are writing something like list to say that this is kind of type of a list, right? So here I am writing, here I'm initializing a variable called Sam object, which is kind of, which is of the type dog, right? So dog, and then if these two were not mandatory, I could have just written this, right, to create a dog kind of a object. But these two, since these two do not have any default values attached to them, I need to define breed and name for that dog mandatorily while creating it, right? It's like, whenever a new person is born, right, so you need to name it, right? So as to keep track, right? So that's why we have to mandatorily put these two, by since by default we are not naming or breeding, right? So not assigning name or breed. Okay. So that is that. Similar to that, we created one more object called Frank. Okay, so we assigned the breed as Husky and the name as Frank, and we created these two objects. Okay, so let's just run these two codes. Okay, so now what has happened till now is that uh, you know uh, there are two attributes of this dog which got stored under these variables. So if you want to see the flow, so breed breed is equal to lab. So the value of breed becomes lab. Okay. So whenever it goes in, so what this is doing is that it's saying that breed value has been assigned the value of dog. Okay, string is dog. Then it comes to here, right? So this value is dog, and that then it gets transferred to this attribute breed underscore ATR. So now this object, if we call the attribute breed ATR, it will return us lab. Okay. So no, so attributes are not mandatory, right? So here I have taken it just to give you an example. Okay. So attributes are specific features of a particular class. Correct. That is correct. Right. Okay. So now let me just quickly show you how we can extract a particular attribute from an object. Right. So since we have ran these two lines of code, now SAM object internally has a lot of information. Right. So it has information stored in its certain attributes. The name and the breed are stored in this particular object itself, right? So let's try to extract that, right? So here the attribute name is breed underscore ATR. Okay, so the syntax is you have to just write a dot and you just write breed underscore ATR and run it. So it says lab, right? So how did it get its value? From here it went to breed, since this is under dog, so it went here, then it went here, and then it got transferred here. Okay, that is why whenever you initialize a kind of an object, you will end up having that as an attribute, right? So in the breed I have passed it. Okay. So just for demonstration I kept these two names as separate so that you understand the flow, how the variables are passing. Okay. So here if you write breed, it will not work. Okay, because there is no such attribute as breed. Okay, uh, dog has no attribute breed. Attributes are something which have to be defined along with self, right? So this is a very important thing, just keep this in mind. So self keyword has to be there. Self dot whatever you write will work. Okay. Okay. So now let's move on to the next part. So you want to see a few more things? I'll just show you. Let's say I just write here. If I just write, let's say name it, yeah. So it must have stored Sam. Yeah. So name went from here to here. Name is inside dog, so it went here, and then name from here, it got this value, right? And then it got stored in the attribute, which is name underscore ATR. Okay, that is how we are able to extract name from the object Sam. Okay. Similar thing you can do with the Frank object as well. So you can just check, right? So this is that, and read it. Okay. Sure. So let's just move on to the next part. Okay, so I'll just rename it to breed itself. Right. So basically, two attributes I have created, breed and name, which will get values from here. Okay. So okay. Now let's move on to the next part. Okay, so I just showed you how this is working, right? So now that name is an attribute, this will work, and this will give you the name Sam. This will give you the name Frank. Okay. Uh, Now let's move on to the next uh, thing that you can do inside a class, which is methods, right? So just note that in case of attributes there are no parentheses involved, right? So attributes are like values, right? So static values. It has no functionality, correct? So let's just look at the exact definition. So an attribute is a characteristic of an object, so it will have uh, just a value, right? Whereas a method is an operation that we can perform with the object, right? So it's like a it's like append that you do in list type of objects, right? So you are basically playing around and modifying the list object that you created with those methods, right? So you're basically essentially modifying it, correct? So you can just see it, right? So here uh, there was an empty list, right? It was of list type, so this object is of list type. uh, you did something called append, so it changed the object, right? So initially the this variable had was empty list. Now when you do a method append onto it, it got changed, right? So the object itself got mutated, right? So now it has one item added to the list, right? So you're basically essentially modifying. So to modify we have to write methods. Okay, so let's see how we can write our own set of methods. Okay, so for that we have taken one very intuitive example. Okay, so here I am defining a class called circle. So till this part, attribute part, anyone has any doubts? Comparison of defined class with an existing class. Yeah, a good question. So basically, inbuilt class versus something which you define on your own, right? So as I said, right? So list type of objects are kind of predefined. So you have all sort of predefined type of classes, right? So you have studied throughout this week and the previous week. You have studied just the uh, predefined type of classes or types, right? So integer is one type, right? And then you have um, floats, booleans, lists, dictionaries, tuples. All of these constructs are defined internally, right? So you know went ahead and played around with that. Now, how do you define own type of classes? So that this is how you define it, right? So okay, so now let's move on to the next one. So cool. So now that you have understood the attributes, let's start with methods. Okay. So how do we create methods, right? So you saw how we create attribute, right? So right now we are defining a type of a type which is called circle, a class which is of the of which is called circle, right? So I have defined circle here. Okay. So, what will be the attributes? So, a circle will have many attributes like radius, area, perimeter, right? So, these are the things that define a circle, right? So, you want to add, so if you want to create objects of the type circle, whenever you query that object, it should uh, give you those details, right? So it should be, so if I create an object called circle, I should be able to extract the radius, area, perimeter out of it, right? So uh, so let's just define uh, a circle type of class. So here, as you can see, I have defined I want to define an attribute. In fact, two attributes. One is radius and one is area. Okay, so I'm defining two attributes for my class. Okay, so for radius, I have a default value of 1 which I have set, right? So if you do not provide me a default value, I will assume that it is 1. Okay, when you create that circle kind of an object, by default it will have the value 1, okay, as radius. So that is why the radius value I have set it to 1 by default. If the user provides something else, it will, of course, come here, right? But the default I have set it as 1. So whenever someone provides a radius, it will flow through this radius and it will come to here, and then it will flow to here. And then it will get stored in an attribute called radius. So since I have written this with self, okay, since I have written this whole thing, self dot radius, so this will become an attribute. Okay. Now area, I'm not taking it from the user, right? Because I can calculate it. If the user provides the area, that characteristic which is the if the user provides us the radius, area is some attribute which I can calculate and keep it, right? So that is what I'm doing. So radius into 3.14, and this I'm storing it in area. Okay, so two attributes I have defined till now, right? So now I will introduce a new thing which is a method, right? So how do you define methods? So for that, what you need to do is you need to write def, and the structure is uh, similar to how you write a function. Okay, but here you have to necessarily put the self keyword, okay, as the first argument. That is the only catch, because this is where information passes from the init group to the methods, right? So this self is kind of containing all this information which it is passing to each and every method. Okay, so I want to write a method called set radius. So what this method will do, given any circle, it will just set the radius to whatever value I give. Okay, so this is the utility. So uh, as I explained, method is something which is used to modify the objects, right? So right, so if you do not use self, you will be in trouble. It will not work. Okay, so this is how you have to pass on the information through self. Okay, so this self says that this function kind of belongs to this particular class. Okay, of course it is written inside it, but how does this information flow here? It flows through self, okay, internally. Now so set radius, so Set radius will have its own arguments, right? So any function has its own arguments, basically the inputs. So set radius, since the name is very intuitive, it wants to set the radius. So you need to, of course, give a new radius, right? So whatever radius you give, it will set it to that value. It will replace the old one and set it to new one, right? So how do you write that? Very simple. So again, inside this method, I'm just writing self.radius equal to new radius, right? So whatever during initialization, whatever radius is there, it will of course be here, right? In self.radius. But if someone is calling this method with a new radius, it will get updated. Okay, as simple as that. Now, of course, since I'm setting the radius, I don't want to keep the old value of area, so I want to renew that as well. So I'm just writing self.area equal to new radius into 3.1. Okay. There is another method that I am defining. Okay, so there is another method that I am defining, which is called get circumference. Okay. So here, as the name suggests, I am not setting anything, right? So I'm not modifying anything in this method. But what I'm doing is that I'm doing some minor operations on whatever existing information is there, right? So I can always do that. So I just want to get the circumference. Of course, I can create an attribute out of it, right? No issues. But just for demonstration purpose, I created one more method so that you understand that not always your methods will modify the object that you have, right? So sometimes it might do some different functions. It's just extracting something and giving it to you. That is also one utility. So method is something which is, operating on top of the object, right? So uh, just to demonstrate that, I have created it as a method, right? So get circumference. Okay. So now what happens is that you can just, so here it will not take any function. Of course, you have to not take any argument, right? So I have not written something self comma something. I have not written that because it does not require anything. But self always has to be written, right? Inside a class, whenever you are creating methods, attributes, self has to be written. So now, what will this function do? So this is like any other function which has to return something, get circumference. So it has to return the circumference value. So I'm just returning this value, set self dot radius into 3.14 into 2. So this is basically 2 pi r, which is the circumference of a circle. Okay. So now that I have constructed this whole class, okay, how can I use it? Okay, so this is the thing. Since I have already mentioned a default value, you can see I can just create a instance or an object of the type circle by just writing C is equal to circle parenthesis. Here, if you observe, I have not passed on the radius, which is totally fine because the value is already there. Okay. Now, how do you extract the attributes? So you have to just write c dot radius, c dot area, and you will be able to extract those values, right? So see, I have just written c dot radius, c dot area, and printed it. So it says radius is 1, area is 3.14, which is correct, but because just default radius will be 3.14 will be the default area, right? Now, how do you call method? If you remember from the list thing, which I have been, giving you as an example. So list dot method name and whatever parameters are there, you have to write in parentheses. Right? So here get circumference does not have any parameter or any argument or any input, whatever you call it. So I can just write c dot get circumference. But here, since this is a method, I have to write a parenthesis. Okay. So I can just do that, and you can see it is calculating inside C whatever is the radius, it will just calculate the circumference and return it. Okay. So is self dot radius a global variable? No. So do not confuse with the local and global scope here. So no. everything that you write inside a circle belongs to the circle. Okay, inside a class belongs to a class, right? So uh, do not try to experiment with, otherwise, right? So no, not essential. Of course you can, play around with this is a very interesting thing, right? Python, you can play around and waste a lot of time, doing some experiments whether this is working. you know um, if you write a function outside, what will happen? If you write it inside, what will happen? All of these things, it's good to have clarity, it's good to have do experiments, but not required, right? So these are very basic topics. Experiments are already there in your curriculum, so don't worry about that. Do not waste much time in, playing around with stuff, otherwise you'll not be able to proceed forward quickly, right? So you need to prioritize your time well, right? In between, as in, need to give sufficient time to a particular topic and then move on, right? So because a lot of things are there, Python itself is like a, a PhD course. You can just go on learning, will never end. Okay. Okay. So I hope this, till this part, how do you construct a class with attribute, and uh, and how do you write methods on top of it? This part I hope everyone is clear, right? So can I get a heads up on that? uh, okay, okay, okay. So yeah, so I think, yeah, so I hope I have tried my best to, reduce the complexity of this topic, right? So hope everything is clear. Now we'll do one more thing, right? So here we have utilized radius, area, and get circumference. It's time to play around a bit with the radius part, okay, before we move on to the next topic, right? So let's just try to set a different radius or a new radius to this circle, okay? So C is a circle which was working on default area. Of course, here itself I could have done something like this, right? So it will give you values corresponding to the radius value 2, right? Here itself you can do that, right? But let's try to utilize this method to set the radius. Okay. Class has attributes. Does method has attributes? So no. So a class will always only have attributes. So even if you write, let's say, a new thing, so interesting question. So if you just write a new thing, let's say self dot a, right, is equal to, let's say, I set it as a default value, right, whatever. Okay. So since I'm using the keyword self, which is inside of a class, everything that you write with a self is an attribute of the class. Okay, whether you write it here or you write it here does not matter. Okay. So of course, one particular thing that you need to be conscious about, uh, a attribute will become available for this class only if you have run this method, right? It is not running this method by default. By default, what it is running is this one, right? So you can just think of this init as a method which runs automatically whenever you are doing an initialization. Okay. So inside of any other method, if you write some different attribute, of course it will become an attribute of the class, but for that to happen you have to run this method manually, right? So let's demonstrate this as well, right? So for now I'm just commenting it. uh, Right. So if you want to retain the value of radius, yeah. So basically, whatever is the new radius, you just want to reset it, right? So the old value has to be reset inside of it, right? So let's see how we can do that, right? So I'm just writing c dot set radius 4. So basically, this method I'm invoking now. Okay. So uh, this method I have invoked c dot set radius. as 4. So what this will do, set radius with a C. C is what of what type? C is of the type circle. So how this line will be comprehended by Python? Let's go into the steps. C is a class of the type circle. Okay, and dot set radius, and then there are parentheses. So it's basically a method, right, which has a value of which has an input 4. So now once you write this and run this line, Python does two three things, right? First thing is it has to learn what is C, right? So what is C? So it will dig into the code to see what is basically C, right? So it saw that C is nothing but a type of a circle which is defined in this line. Okay, and this is basically a circle, right? So the Python now knows that C is nothing but a uh, of the class circle. Okay, so it goes to this code, right, and sees as to what is there in this class, right? So of course, otherwise it will not be able to process things, right? So it knew from here that it is a circle. Now it will go here and see what is there inside a circle. So inside circle it sees a method called set radius. Okay, so set radius is found. So Python is happy now, no errors till now. So it went to circle, saw a method set radius. Now it says that this set radius requires a mandatory argument, which is new radius. Okay, so even if you do not write the name of the variable like this, right? Even if you do not write the name of the variable that you need to pass like this, it understands because that is only one one input, right? So Python got to know that 4 should be my new radius value. So it goes here, it goes here, it sets the previous radius to 4. It goes here, sets the previous area to 4 into 4 into 3.14. That's it. Now it's done. Since there is nothing to return, it will not return anything, right? Because you see, if I just run this, it will not return you anything. See, it has not returned you anything because this method did not have a return statement, right? But what it did internally is what was expected, right? So can you write what will be the value of c dot radius? If I just print this c dot radius, what will be the value? So just write c dot radius equal to whatever you think would be the value. Okay. So c dot radius. Also write the value of c dot area. What do you think will happen? And what do you think will happen when I now call after running this? If I now call c dot get circumference, what do you think? What will these values be? So write all of that. So c dot radius equal to what? C dot area is equal to what? And c dot get circumference, what will this return? Okay, so all of you think that c dot radius, which is the attribute, Python will set that to the new radius 4, which is correct, right? So that is correct. Okay, so c dot area will become the value that will calculate basically 50 point something, and c dot circumference. So Sriram, you cannot write c dot circumference is equal to this. It's just that c dot circumference parenthesis will return you that value, right? So circumference is not a attribute here. Circumference is a method which will return a value. So in parentheses you have to write. Okay. So correct. Circumference is 2.25.12. That is correct. Correct. Yes. So it will do whatever is desired, right? So yeah. You want to play around with this? You can just run this to see if this is working, right? So 450.24, 25.12, right? So okay. Now this is one part that I wanted to show you, right? So I'll just show you this part and then we'll move on. Okay. So right now this a attribute is not there because I have not run this part of code. Neither I have run this part, right? So this is commented out. So if you just want to see, does C have an attribute called A? What does this say? So says the circle object has no attribute A because we have not defined it yet. So let's just define it here within the method. Okay. Okay. Now let's define this. Let's run this again. Okay. So everything is clear till now. Now if we do C dot A, do you think it will be there? What will this do? Can you just tell me C dot A if I now write, because I have written it self dot A is equal to this value. Okay. And I have initialized this C is equal to this again. So I have just ran these two blocks of code now. Okay. Now if I write C dot A, how many of you think that A is there? So will it throw an error or not? Can you just write yes or no? Error or no error? Error or no error? So I have run this code. I have run this code. Now can you tell me whether uh, A is A attribute is available in C or not? Right. So I have just written this, wrote this, ran these two afresh. Right. So now can you say me whether C dot A is something which will work or not? Error, no error. Okay. No error, error. Okay. Okay. So I'll tell you why. So let's just first run it. Okay. Of course, you can see uh, there is no there is the C attribute is not available, and that's why it threw an error. So circle object has no attribute A. Why is that? So now we'll say that I have already written this, but why is it giving us error? This is because as I said, so whenever you are doing this line, right, C equal to circle, okay, so it is running this part by default, right? But it is not touching the other parts. Okay. So this method, even if you had a syntax error in your method, or in your even if you had some kind of error in your method, right, in your get circumference, that will not be triggered because that part of code is not run by Python yet, right? So no one has called dot set radius so that this code can run, right? So this code has not run yet. So whenever you are doing C equal to circle, this code has been run by default by Python, right? Because this is the inbuilt method which gets automatically invoked whenever you are initializing or creating an object of a particular class, right? So that is why it threw an error. Now let's say we just set some radius, right, to trigger this code. Okay, so let's just trigger this part of the code by writing set radius. Let's say whatever, right? So 45, let's, does not matter. So I'm just setting the radius so that this part of the code is triggered now. Now if you do C dot A, You can see you got your random value, whatever was there, right? Because now this part of the code ran completely. Okay, so I hope this till this part everything is clear. So difference between init and set radius. So basically init is like a inbuilt method which automatically runs whenever you are initializing an object, but the other methods that you define will be invoked or will run only when you basically call that method, right? So these codes will not run by default. This is what will run by default when you are writing this part of the code. Okay. Okay. Great. So mm, okay, everything is clear till now. Okay. Okay. Great. Uh, Great. So let's move on to the next topic, which is polymorphism. Okay. So don't get intimidated by the name of it. A very easy topic. Okay. So okay, so this I want to show you through examples, right? So it will be much more clear. So let's just you know build two type of objects. Okay, so uh, one is let's say two type of classes, right? So one is, let's say, class house Stark. Okay, and then there is another class which is called house Lannister. Let's say these are the two things that I defined. Okay, so now I want to have sigil as the default attribute for this class. Okay, so I by default I want to have sigil attribute inside of class. Okay, so what it does is that, to do that I have just written sigil as the mandatory parameter because I have not passed on any default argument. And then again, our routine works. Sigil will go here, and then sigil will get stored in the attribute called sigil. Okay. Then I have defined one method which does not take any argument. The name of that method is moto. So whenever I call this, it will return me something. It will return me a string. Okay. So this string is what it will return. So it will return how Stark with sigil, and then this is just string concatenating. So I'm just adding strings. Okay, so in the self dot sigil part, whatever sigil you have provided, that string will get added here. Okay, and then it will say how Stark with sigil this has the motto winter is coming. Okay, so this is the statement or the string that this method moto will return. Okay, it does not have any parameters, right, or any inputs. You have just written self here. Exactly similar thing I have done with house Lannister. So it will also take sigil, and just note that both these two attribute names are the same. Okay, so I have just kept the attribute names as same for these two classes. Okay, now okay, so this has the same attribute as house Stark, and this house Lannister also has the same name of the method, which is moto, exactly motto. This is the same in both the cases. So I just want to check whether Python confuses or not. Okay, so very small experiment. Okay, so house Lannister with sigil self dot sigil has the motto "Hear me roar." Okay, so this is the motto that it will return. Okay, okay. So now I want to create objects. Okay, so I created an object called Arya, and the class is house Stark. Okay, and the sigil which is mandatory, which I have provided as direwolf. So this is like a string that I have provided for the value of sigil, right? So I can also write uh, sigil here. So this is also one way to do it, but since there is only one argument, I can just avoid writing this as well. So no need to write, right? So uh, direwolf is the sigil that I passed. Okay, great. So now there is the second class, right? House Lannister. I'm initializing one object of this type as well. Okay, so I have just written Tyrion is equal to House Lannister, Golden Lion. Okay, so if you just check the type of Arya, so it says main house staff. So you can just print it. So it will also say that it is a class, right? So class house staff Arya, of course, because it's the class is house staff and Tyrion. Okay, so you can just write this as well. Tyrion. It belongs to House Lannister. Okay, so we have initialized it correctly. Now, if I print aria.moto, okay, so aria.moto, what will it do? It will basically uh, go to, since aria is of the class house tag, it will go to the moto part here and then it will return this statement. Okay, that is why it has returned house staff with sigil direwolf. So how did this value come here? So you initialized it with the value direwolf, so this part of the code ran. So self dot sigil got initialized. Now sigil attribute got put into the system, right? And then aria.moto is what it is doing, right? So basically now you are running this method, so it will of course return you this, right? uh, Now if I write aria tyrion.moto, okay, so how many of you think that Python will get confused and start printing this itself? What will this print? Tyrion.moto. So this line, Tyrion.moto, what will this print? Will this print this type of a sentence or this type of sentence? First one or second one? Which one will it print? Tyrion.moto. Which one will it print? Second one, first one? Or will it throw an error saying that Python got confused? What will happen? First one will get printed or the second one, or will it throw an error? Okay, okay, great. So you understood this, right? So now that you have answered second one, this shows that you have understood polymorphism as a concept. This means that Python will not get confused and it will look up in this class and run this particular method and not this one. Okay, this is because Tyrion itself holds that information that it is of the House Lannister instance. So if I just hover over it, you can see House Lannister instance. So it knows that it belongs to this particular class, and that's why it will invoke this particular method and not this one, although both the names are exactly the same. Okay, so this is the beauty of Python, and it is used in this concept is used in many places, right? So you have whole lot of code, you do not remember which class has which method, which class has which attribute, right? You do not keep track of that it if you write, let's say, 2000 lines of code, right? So in that case, Python should be able to understand what is written inside each one of them and act accordingly, which is what it is doing, right? So this is what is the concept of polymorphism. So now there are just ways to so that this as a concept, this can be used in various constructs, right? So I just wrote this aria.moto, Tyrion.moto. What I can do is I can run a for loop, which will again take each one of these values. And since the name of the method is same, I'll just do this and it will print likewise. So for warrior in Arya dot comma Tyrion. So these are the two objects of which I have created a list. Now I'm iterating over that list to go from one object to other, right? So first it will take Arya. So this is the first member in the list. So Arya comes here. So warrior value will become Arya for the first iteration of this for loop. So Arya comes here, right? Arya dot moto is getting executed again. So it is essentially basically the same thing. Okay. So it will print house dark with sigil that has the motto just this. Again, the second point, second item in this list is Tyrion. So it will go and this warrior value will become Tyrion. Then it will come here. So Tyrion dot moto is essentially what it will become, and it will print out this line. So you can see for loop is working and it is printing out both these lines. And this is just to show that moto word is exactly the same. Moto method name is exactly the same. Okay. Okay. Great. So similar thing you can do. You can write a function get moto, and then you can pass a warrior, and this function is basically printing warrior dot moto. Okay. So if you just do get moto of Arya, it will do Arya dot moto and return you this Tyrion dot moto, and it will return you this. Okay. Great. So now we'll move on to the second topic for today, which is error and exception handling. Okay, very interesting part, right? Uh, so you might have encountered many errors, right? So if you just write like this, you have opened a bracket and that this string is continuing, and then you run this. This does not make sense. It will throw you an error, right? So you have to structure things well so as to make Python understand that what you are saying, right? So syntax error is one type of error that you have probably encountered, right? And maybe many more errors that we saw, right? So something like this list does not have this attribute and all of that. So these errors come in, right? It's you should always try to develop a sense of understanding what the error sentence is saying, and then accordingly acting on that, or maybe doing some Google search to see what is the problem. Okay, so this is a very good habit to have, but to handle exceptions. But how do you handle that in code so that your code, if some systematic errors, non-systematic errors come in, right? So which you are not expecting, let's say, okay, how do you handle that? Okay, so that is what we'll try to see. Okay, so there is this construct called try and except, right? So similar to if else that you have studied. So if this happens, do this, else do this, right? So you have studied this kind of construct. There is a similar construct called try and except. So what you will say, try to do this, if this fails, do this, right? So it's kind of if else, but it's the condition to trigger the else part is when error hits in the if part, right? So you can think of it in that manner. So this is the syntax for that. So you just write try and then colon, and then you write all the operations that you want to do. Okay, now if any errors come in this part of the code, only then it will move to the except part. So except and then this block will be executed. So if there is an exception, then execute this block. Else, if there is no exception, then execute this block. So try except else is the construct. Okay, so whatever you want to do first hand, write it here. If this fails, this gets executed except, right? If it does not fail, else gets executed. Okay, try this, if fails this, else this. Okay, so as simple as that. Okay, so else part is important, as in you let's say if the code did not throw an error, right? So if there is no exception or no error in the try part, probably you want to print something like print the code ran successfully, something like that. That's why you can, that's where you can write else. Okay, so that's why. So try except else framework. okay, to handle errors in code. So let's just run this. Let's just try to visualize this. So I have just written three statements: try, print good to go, except, print oops, and then in else I'm printing no errors encountered. Right. So okay. So these are the things. Let's say if I just run this, what will happen? It printed good to go because this was a correct statement. No errors were there. So it printed this. This except block did not run because there were no errors here. The else block got executed because everything went fine in this part. So no errors encountered. Okay. So it printed out two statements. Okay. So now let's try to induce some errors in the try block. Okay. And see what happens. Okay. So I'm just writing print a name of a variable which I have not defined yet. Right. So this will throw an error. So now if I run this, what will happen? Can you so you can say that this will throw an error. So the expected flow would be to go into the except part and print that. That's it, right? So you see, this did not run. That's why it went to the except block and then it printed oops. Okay, so uh, this part will only run when there is an error in this part. So if you want to see the error that was incurred, of course, since you have written try except else, that error did not get printed out. But if you want to see the error, see, this is what would have happened if you had not written a except statement. This code would have not worked well, right? So right now, you can see it would cause a name error saying that this name is not defined, right? So yeah, so I hope this part is pretty easy and pretty clear to you guys, right? Okay, finally, so yeah, we'll come to that. So there is this, so here you can see, since since there was an error, so the else part did not get triggered, right? So there might be some case wherein whether or not a code runs or does not run, it throws an error, it goes into the except or whatever it becomes, whatever the state of the code is, you want to finally do something, right? So let's say that's where we use the keyword finally. Okay, so you want to write some you want to try out some code here. If it runs, it's fine. If there is an exception also, it's fine. So it will always print this finally block. Okay, so try code. So you can write your code block here. All these codes will be executed. Let's say there are 5 lines in your try block. There are 5 lines of code, right? The first 2 lines ran well, but in the third line itself, it threw an error, right? So first, second line got executed, third line threw an error. So, but your fifth line was something which you anyway want to run, even if the third one fails or the fourth one fails. That final statement, let's say the fifth line of code, you want it to definitely run. Okay, so in that case, you can just write that part in finally. Okay, so try this and then finally do this. Okay, so let's just run these statements. So in try, I have written print statement saying execute try statements. Okay, and then finally print always execute finally block finally code blocks. So you see this these two statements got executed. Okay, so we'll try to induce some errors to see what is happening. Okay, so now I have defined two variables a and b. A is equal to 1, b is equal to 0.2. Okay. Now in the try statement, I have written print a comma type of a. So I want to print the value of a and the type of a. Okay. In the except part, I have written print b and the type of b. Finally, I want to print type printed, right? So whether or not this block is running, this block is running, I don't care. Finally, it should print type printed. Okay. So this is what my intended, uh, you know, uh, intended behavior is. So let's just run this code to see what happens. Okay. So it went ahead. It printed the value of a, printed the type of a. Since this part of the code did not throw an error, it did not go to the except block. You see, there is no mention of this b. B is 0.2 and the type is float. But that part of thing is not printed, right? So except part did not get executed. In the finally part, we have written type printed. So it has printed type printed. Okay. So now let's try to induce some errors and see this statement is getting printed or not if it goes into the except block. Okay. So let's try to induce an error in the try statement. So what will happen? So let's say I just print, induce a third random variable which I have not defined. Now this part will throw an error. It will go to the except part, and then finally it will print type printed. Okay, so let's just see. So yeah, this is indeed what is happening here, right? So you went to try, you induced an error. So this part of the code did not run. Then it went to the except part. It printed B and then type of B. Okay, 0.2 and class float. Finally, it printed type printed. Okay. So you understand the difference now, right? So why, how else is different from finally? Finally is something which will be executed if you, does not matter if your try runs or except fails or try fails, it will anyway execute this. Else construct is something which will get executed if the try statement runs without errors, right? So this else is basically for except, right? So so try this. If it does not run, go to the except block, and if it runs, go to the else block, right? So this is the difference. So try except finally and try except else. So two type of constructs, right? So now let's take another example of nested try except to make it more clear, right? So it's not that you have to just write try except finally only once. Inside of this try, you can write thousands of statements which can have its own try except finally if loop for loop whatever, right? So this is just a construct. Inside that you can write whatever you wish, right? So this is what I have done, right? So I want to try these statements. Okay, I want to try this part of code. If this part of code fails, I want to run this part of code. Okay, and here itself I have written three sentences. So basically a equal to 1, print a, and then I have included another try except block here saying that try to print this part. If it fails, print this part. Okay, so does not matter what is happening here. If this entire thing gets an error, if this entire thing gets an error, it reaches to this stage. Okay, so let's try to run this. What will happen? So what happened is that it went here, a is equal to 1, print a. So this ran fine. So a value was printed. Okay, now it went to the try loop. Then it wanted to print the type of this, but this variable is not defined, right? So we did not define this random variable, right? So this part threw an error, and that's why it went to this part and executed error occurred. So it wrote error occurred. Since you have already handled the error part of this here itself, this whole part of code will be said to be, you can see that this part of code has not been executed. That means Python is uh, saying that I did not see any code in this part of the program. Okay, so this is what Python is saying, because you have already handled the error of this part in try except itself, right? So if you take a step back and look at this whole picture, right, there was no error in this particular thing, right? So it ran without errors. If you want to see this, how this independently works, right? So this part of the code, I'm saying this part of the code ran without errors, and that is why it did not move to this part. Okay, so if you independently run this chunk of code, you can see there is no error that has been printed, right? So there is nothing like name error which says that this name is not found or not defined. Any error is not getting printed. So this part of the code is running totally fine, and that's why in the except block they has not entered, right? So when will it enter in the except block in this case? In this case, when will it enter the except block? So when you write something which has not been handled by try except, right? So let's say I just write one statement outside of this try except block saying that there is one variable that I want to print. I have not defined it. So what will happen now? A is equal to 1, it will print A, and then it will want to print this. But at this point, it will throw an error. Okay. So what will happen? From this line itself, it will skip to this line. So these will not get executed because it threw an error here itself. So it will go here after this line. After this line, throwing an error, it will go here itself. So let's just run this. You see, A is equal to 1, print A. So A was printed, and then it wanted to print the type of this, but it could not print. Okay, so what it did, it went here and then printed the error is ex. So what is ex? I will come to that. But then it printed this whole thing. Okay, and then it printed b comma type of b, which is from previous we have point 2 and float. So it printed that part. Okay, so now comes what is this ex? So till now we were not writing exception as ex, right? So what is this ex? So here what happened is that uh, whenever you are running a part of code and you are basically by force you are subsiding it with an except statement, you are losing out on information, right? So what error occurred, right? You do not know that. But how do you try to log that part? So you write something like exception as ex. So basically ex is the variable that I am creating to store the exception that we have hit, okay, or the error that we have hit. So this error, so this is the syntax basically, right? Except exception as ex. So now this error got stored in ex part, okay, and now if you just print ex, the error is colon ex. So it said that this part is what the error was caused in this chunk of code, so which is quite expected. This part threw an error, right? So I hope try except part is clear, right? So we have questions. So uh, I have a question with respect to its utility. Isn't it more helpful to get the actual error and solve it? That's a great question, right? So we'll come to that in the real world example that we have just after this. Okay, so of course in the development stage you will definitely have to fix whatever error you are coming, right? So this is not a way to handle errors or to tackle with errors in development mode, right? This is something which is production grade programming. So when your code runs automatically, at that point what happens, right? So to take care of those errors, okay, so we'll come to that with an example. So if there is an error in except part as well as then what happens? Good question. So let's just try to see what happens then. Okay. Uh, okay. So Prashant has already answered. So then you will get an error and the program stops. That is correct, right? So in the except part also you have an error. Now there is no way to handle it, right? So it will just, the program will just stop there, right? So yeah, you can try this out yourself as well. Okay, great. So I think we have covered exception part. So these two concepts we learned right today. Object-oriented programming. Of course, OOPS is itself a very big topic. I just give you a flavor of how things work in the hindsight in Python, and of course, we studied a bit of error and exception handling, and these two are very important parts of production grade programming, right? So we got a brief idea of these two. Now let's see how we can utilize these concepts through a real world use case. Okay, so the example that I was quoting you before the start of the class, right? So the Uber's example. Okay, so whenever you request for a cab in Uber, right? So what happens is that uh, you enter your pickup location, you enter your destination, right? And then based on the distance and whatever reasons, right? So whole lot of things are considered by Uber to come up with a final price which is shown to you. You see that price and then you request for the cab, right? So only when you see the price you request for the cab, right? So yeah, so how does Uber come up with the price of what it wants to show you, right? So it has to take care of a whole lot of factors, right? So what is the distance between the 2 points, right? Whether surge pricing will apply or not, right? What kind of customer you are. So can you just write a few things, right? So let me just clear this. What do you think? So what are the deciding factors in price? I'll just clear this. So what are the deciding factors in price? So in Uber, uh, whenever you request for a cab, it shows you a price. So what can be the uh, things that is considered by Uber to come up with a price? Distance, right time. Okay, correct. And right time, what is the right time? So uh, right time you will never know exactly before you complete the ride, right? So right time is expected right time, or predicted right time is what it probably takes to get a proxy of the right time. uh, Whether it is peak time or not. Okay, so peak time it will take surge pricing. Traffic condition will again determine how much time it is taking to reach the destination, right? So of course, whole lot of things, right? So of course these are the things that you think Uber should consider, but of course Uber considers a lot of things, right? So demand is one which many of you have written. So how much is the demand in that area, right? So if the demand is very high and the number of cabs in that region is very low, it will obviously want to charge more from the customers, right? Saying that whatever supply I have, I need to maximize my profit by doing the rides in this area, right? So less uh, less supply and more demand, that means that in that area people will be willing to pay more, right? If one person will not pay, someone else will pay, right? So because there is a lot of demand. So of course demand is one. What other things? Just think about it. It's an interesting thing to think about, right? So number of cabs in the region, okay, which is kind of supply, right? Type of vehicle, right, which is correct, right? So whatever type you are requesting, how regular customer you are, membership if any kind, distance, great, great. Petrol price, okay, that is something, probably it is looking on a macro view, right? Weather, cool. So a lot of suggestions, which is very good. So one particular thing which you might not imagine, right? So it has probably studied a lot about you through your booking behavior in the past, right? So probably whatever price Uber shows, you never go to Ola, right? So you always book that. Uber knows this. If Uber knows this, it will show you higher prices, right? So customer behavior based on past data, customer segmentation. So there are a whole lot of segmentation modules that are there inside Uber, which classifies customers under different categories, saying that this customer, kind of seems like very insensitive to whatever price we show. He will anyway book. Then there is some segment which he knows that after price, this guy goes to Ola, right? So, or no, just closes the app. This, so there will be a separate segment for that. So all of these models are working in the hindsight. Thousands of lines of codes are running automatically as soon as you select the from and the to. So just try to imagine this, right? So as soon as you select the from and to, and that milliseconds or the few seconds that it takes to show you the price, thousands of lines of codes are running in the background. Maybe machine learning codes. I know some information is coming from this table, some information is coming from this table, this source, traffic source, and petrol price. Whole lot of things are coming together to predict that final price that it wants to show you, right? So that it can extract the maximum out of that ride that you are taking, right? So now imagine of a situation wherein of course there is one aspect, right? So it has to definitely calculate the distance. So Uber does not have its own maps, right? So Uber does not own maps. So it takes a third party service from Google to get the distance between 2 points, right? So that is one part, right? So it has to interact with a lot of sources to come up to a price, right? And each of these sources have their own tendency to fail, right? So what if Google Maps does not give the result of the distance between 2 points? So if I say the pickup location, drop location, send it to Google to get the distance between these 2 points. What if Google fails, right? What if that Google API or the code that is providing us the distance from Google, that part fails, let's say 1 in a million times, right? How do you as Uber make the system foolproof, right? So in that case, what you do necessarily is you try to handle these errors that might come in, and there is no developer that is writing and running the code and finding the price for you, right? It's all happening automatically in the background, and that's why you have to use these try except statements to circumvent any kind of errors that might creep in into the system, knowingly unknowingly, right? Of course, knowingly, whenever you are developing that system in the development mode, you are of course fixing all the errors that are coming. Of course, you will not have syntax error in your final code, right? But what about the codes which are dependent on others, right? So if that throws an error, what happens, right? So in those cases, you need to utilize this try except statements, okay? So let's just come up with uh, a model, very simplified one for Uber to understand the concepts and utility of try except and classes maybe, right? So when you request for an Uber, you enter your pickup location and destination based on the distance, peak hours, willingness to pay, and many other factors. Uber uses a machine learning algorithm to compute what prices will be shown to you. But let's just consider a simplistic version wherein the price will be calculated based on the distance between the pickup and the drop location and the time of booking. So I'm taking the time of booking just to, add a little flavor of surge pricing, right? So uh, based on the time of the day that the cab is booked at, I will decide the price. Okay. So the user inputs I'm taking as pickup location. So how do you capture the location? So it's nothing but a latitude and a longitude. So each location in the entire world has a unique latitude and a longitude, right? So pickup location can be, given by two values: pickup latitude and pickup longitude. Drop location again will have two inputs, which is drop latitude and drop longitude. And time of booking, basically the hour of booking is what I'm taking as, again, as an input from the user. Of course, the user is not typing the time of the booking. It is automatically captured through the system because the system knows at what time you are entering, right? So this is kind of a auto reduced variable that is already getting captured, right? Now it is calculating the final price, right? So till now, whatever things you have studied, right? You have studied Python, like let's say till yesterday's class, whatever you have studied, how do you approach this problem based on that? Okay, so this is what is development grade code, right? So what you will do is that you will write a function probably to get the distance between the location 1 and the location 2, which is let's say the pickup location and the drop location, right? So you want to get the distance first. Okay, so here, just to take a proxy, I'm just taking the distance as the Euclidean one. Okay, so um, so there is one library in Python which you do not need to bother about, which I'm importing. This basically helps in calculating the distance. This is not the scope for this lecture, right? So you just need to understand there is one function which I am writing to get the distance. Okay, so this is the line of code that I have written, which gives me the distance in kilometers. Okay, so given any location and any pickup location and any drop location, it will give me the distance, right? Then there is one more function that I have written, which is um, after getting the distance, you need to also calculate the price per kilometer. If you get the distance in kilometers, you need to calculate the price per kilometer. Then you will multiply both of them to get the final price, right? So a price per kilometer, this will depend on the hour of booking, right? So I've just written hour as an input variable, which is nothing but the time of booking, right? So at which hour it got booked. So I've written, I've written that, okay, so if the hour is between 8 and 11, right? So these are basically the office hours in the morning. So I've written in those peak hours, I can increase the pricing, right? So price per kilometer I have set as 20. Okay, in those morning hours, peak hours. People go to office, right? So they book a cab to go to office. So prices and demand will be high in that point. Then you have this another set of peak hours, which is in the evening, let's say from 18 to 21, right? So from 6 p.m. to 9 p.m. You can say that the price per kilometer is 15. Okay. Now, let's say the else part. So in the non-peak hours, I'm setting it as 10 rupees per kilometer. Okay. So this function will basically take the hour, and based on that, it will return the price per kilometer. Very simple function, right? So distance is getting calculated, price per kilometer, get final price. Here, this function will return me the final price. So what this will do, will take the pickup location, drop location, booking hour, and then it will calculate the total distance using this function, actual price per kilometer using this function, right? Get price per kilometer. We'll pass the booking hour to get the actual price per kilometer, and then final price will be nothing but a rounded number of the product of these two, right? So total distance into actual price per kilometer. this I since I want to show it to the end user, so I need to make it to 2 decimal places. So rounding into 2 decimal places, and then this will give me the final price, right? So let's just try to run this part of the code. Okay, so if you do this, pickup location can be given in in the form of a tuple, wherein this tuple is the latitude longitude. Okay, drop location also I have provided in terms of latitude and longitude, right? And booking time also I have provided as booking time I have provided as 19. Okay, okay. So Devendra, so see, we are not solving the actual pricing problem. We want to learn what is production grade programming in this class. Okay, so all those nuances we are, this is why I have written simplified model, right? So this is for understanding Python and not understanding Uber per se, right? So okay, great. So then we have this final price, right? So this comes out to be 225 rupees. Okay, so I have just written basic functions. So this is something which you could have written based on whatever you have learned till yesterday's class, right? So now you want to push this system to production, okay, and you want to ensure that this system never collapses. It always gives you a final price, right? Irrespective of whatever happens, right? So you want to decrease the probability of failure of this system. Okay. So where can you identify what can be the causes of failure? Let's say in a Uber system, real system. Here, of course, I have imported a pre-built library. So in an actual system, as I was giving you an example, this distance might be coming from a third party source, which is, let's say, Google, right? So Google gave you some part of code, so you just write google.maps.distance and you pass on the coordinates of the pickup and drop, and it will give you the distance based on the actual route, right? So whenever Google gives you a distance between two locations, it will not give you the air distance, it will give you the route distance, right? But that part Google is giving you, so it can fail, right? So there is some minor chance of failure, right? So you as Uber don't want that to reflect in your customers side, right? So what do you do then? So you write something in the except part that, okay, if Google fails, let's say I will go to the second best thing, right? So let's say there is one more maps service provider. I want to query that for the distance. Of course, Google is my first priority because it's the most reliable system. But in backup option, I'm writing that, okay, let's say Bing is also doing maps. So I will calculate the distance using Bing's API. Okay, and then there might be another third party through which I want to get the distance. So all of this thing is there, or right? So again, so this can be the failure point in distance. Get price per kilometer. I wrote a very simple if else statement, so this will never fail. But in a real system, what points of failure can be there? So price per kilometer might depend on whole lot of factors, as I said, and whole lot of factors might be coming out from different tables, different systems of Uber itself, right? So all of them have some probability of failing, right? So now if you as Uber want to be foolproof, your all of your systems, so this function should also be foolproof, right? So you'll have a backup plan. Let's say you're not able to calculate the exact price per kilometer. Let's say I let's say never look at the price and book at whatever price you show me, right? So if I am the customer, you can show me a price of 20, right? 20 rupees per kilometer. But let's say that module which says that for me the price is 20, that module fails. So is it acceptable that Uber no, whenever I am searching uh, for a cab, since you are not able to run my specific model, I should not be able to see the price? That should not be the user experience, right? So I should be able to see the price. right? So in that case, in the accept part, you can write that if anything fails, just set the price to a fixed value of, let's say, 10, right? So that my customer is served, I retain that customer, and whatever profits I'm making, it's the minimal, not the optimal one, but I'm making some profit, right? So you can do that. So this is where the try except utility comes in picture, right? So the same thing, if you have to write in a production grade, uh, as a production grade code, so what do you do? So here, let's say this is, let's say, the Google distance provider, okay? And then let's say I can write my own formula as well, right? So let's say if this Google distance formula fails, let's say I just want to calculate the Euclidean distance between the 2 points. That's it, right? So it will not be exact route distance, but let's say I'm still able to serve my customer by giving some distance and quoting some price, right? So what I do is that I define a class called maps, right? So in this maps, there is no uh, there is nothing that I want to run by default, right? So there is no attribute. Okay. So what I do is that I just write no pass, and then there is a method that I defined, get distance. So everything is similar. So I just copied this part, right? I've just copied this part and wrote it here, but I had tried to handle the distance calculation. Okay, so based on two locations, I will calculate the distance. I'll try to calculate the exact distance, but if that does not work, I have written a backup code saying that, okay, uh, let me just calculate the Euclidean distance. So x1 minus x2 whole square plus y1 minus y2 whole square root under. Okay, so this will give me some proxy of the actual distance, right? And then I just want to return the distance. Okay, why I have put it under the category maps is because no, this has some relation to maps kind of framework. So whole lot of other methods and things might be written here, right? Which correspond to map kind of framework, right? So tracking and uh, right time calculation, predicting your expected time of arrival. So all of these can come under this category of maps, right? So that's why this categorization. Then I have written one more class called surge pricing. Okay. So here again, I have in the init, I have written pass, uh, get price per kilometer. This same code I have, framed as a method of this class. Okay. So I have just written this, and then in the except part, I have written that, okay, so if this part of the code fails, which is, very unlikely because this is a very simple part of code, but as I said, there might be machine learning algorithms and a whole lot of other things happening in to get the price per kilometer. So if any of these things fail, I can still quote a price per kilometer of 10, just for to make sure that people are getting the price, right? So this is how I have handled this part, and then I'm returning the price per kilometer. Now in the final price, I'm of course taking the same three arguments: pickup location, drop location, block booking hour. But in this case, I have initialized an object of the maps type. I have initialized an object search for the search pricing class, and then I'm just utilizing maps dot get distance this to get the total distance, search dot get price per kilometer to get the actual price per kilometer, and then the final price again is the same calculation, right? So essentially I'm doing the same thing here, right? To convert this part of code to this part of code, right, to this type of a code, just takes a very few minutes, right? So it's not that a big task, right? But this is a good way to write code. Okay, so here if you just now want to get the final price, of course you will get the same price because everything is the same. So pickup location, drop, and booking time. Okay, so you probably I understand that you have got the importance of try and accept, but why does this structured thing, why do we have to write class and all of that, right? So there is another utility, right? So it kind of makes the code more structured, right? So probably this is not the best example to show this, but it kind of makes the code more structured. So when you have 1000 lines of code, and you want everyone who is utilizing that code to understand it from the code itself, right? Then you need to organize things a bit, right? Similar type of functionalities and methods should go inside a class. So it's basically all this random stuff is there. You are just organizing some things under some class, saying that these belong to this functionality, this belongs to this functionality, this belongs to this functionality, and so on. So it's like organization within the code, which enables whoever is, you know studying your code, he will be able to comprehend that stuff in a much uh, better way, right? So that is why this production grade programming is important, right? So two aspects: object oriented programming, and and of course the error and exception handling part.